Greetings and welcome. In this video session, you will be able to explain practical applications of immersed surfaces and the concept of total pressure and center of pressure. Let us see some practical applications of immersed surfaces. Here we see a hydraulic dam which is used to store the huge amount of water. It is also called as water reservoir. Hydraulic dam is a construction of wall across the river. It is used especially for the electrical power generation purpose. If we see here, this wall is of inclined shape. These are different configurations of dam structures used. So in order to calculate the hydrostatic force on the wall surface, which is developed by the water stored there, this theory is used because from this GIF we see that there is a large amount of force generated by the water when the flow is blocked by the wall constructed across the river. So this is hydrostatic force. In calculation of hydrostatic force, two concepts are required to be studied: total pressure and center of pressure. Total pressure, it is a force exerted by a static fluid, means stationary fluid, on a surface, either plane surface or curved surface, when the fluid comes in contact to the surfaces. This force always acts normal, means perpendicular to the surface. It is mathematically given by the letter capital P, means total pressure, is equal to P into A, and as it is a force, its unit is Newton, where small p is the intensity of pressure at a point in a Pascal, and capital A is surface area normal to the force in meters square. By the hydrostatic law, as the depth of water increases, pressure increases, means intensity of pressure increases. So here the resultant force generated by this water that is acting at some point, that is called as center of pressure. So in this diagram we see it is a point of application of total pressure on the surface. For example, here in this image, this is a center of pressure shown here by this arrow, which is at a depth of h bar. In order to study total pressure and center of pressure, there are different types of immersed surfaces. So here are some types: horizontal plane surface, vertical plane surface, vertical inclined plane surface, and curved surface. Horizontal plane surface, here we see this is the horizontal plane surface which is immersed below the liquid, and this is a free liquid surface. From this free liquid surface, this horizontal plane is situated at a height of or depth of x bar. This is vertical plane surface. Here we see in this image, this is the flow of water that is blocked by this construction of these vertical planes. This is inclined plane surface. Example, here we see this is an inclined fashion. This is a gate which is provided in order to store this water. This is curved surface, means these are the gates which are used or which are mounted on this top of the wall of the dam. These are of curved shape. So at the end of this session, you can explain practical applications of immersed surfaces and concept of total pressure and center of pressure. subscribe the channel Thermal Engineering for further video sessions. Thank you.